On this presentation, I will talk about the current state of creation astronomy. I'll survey where we've been over the past half century or more, where we are today, and make recommendations about future endeavors. However, there are several problems with the creation model, trying to develop a creation model of astronomy. One of the problems is we had lack of qualified researchers. The first generation of creation scientists back 50 years ago were generalists. They had academic fields of, say, engineering or physics or biology, and they naturally then, when they talked about other topics such as astronomy, they were out of their fields. Now, people outside of the field who lack the academic credentials can make contributions, but it's far better if you have people with the academic degrees, the PhD, for instance, in astronomy, and there weren't any back in the early days of the creation science movement. And it's because people who have these academic degrees, they can know the background more than the generalist would, people from outside of their fields. And it's good to know that we now have a number of creation astronomers who have PhDs, terminal degrees in the field, and they better know the applications and the issues that we need to deal with. So we've overcome part of this problem with lack of qualified researchers. Another problem we had is that the Bible doesn't give us a lot of specifics about the astronomical aspects of the world around us. I've always been envious of the biologists, for instance. They do have information about the kinds, the created kinds, and much of their interest has been to develop a creationary model of biology, trying to identify what those kinds are. And geologists as well, they're told a bit about what happened on day 3 when the dry land appeared. Of course, there's a storehouse of information during the Genesis account of the flood, because we think the flood shaped and reshaped much of the surface of the earth at that time. So what do we have for creation specifics? Well, we have space being made either on day 1 or day 2, and I'll talk more about that a little later on. And then we have astronomical bodies made on day 4. It simply says that God made these lights, put them in the sky, in the expanse of heaven. And it says the lesser light and the greater light. Of course, obviously talking about the sun and the moon. And almost as an afterthought, the stars also. And this, I think, this generalizes everything in the sky to the ancients would have been stars. So this would include galaxies, asteroids, satellites of planets, and so forth. Well, that's it. There's not a lot of information there, is there? And so it's been my job as a creation astronomer to try to make sense out of this. And I view this as an encumbrance, but on the other hand, there are some advantages. It can be quite liberating once I understood that was the case, because it gives us a lot of room in order to conjecture many different things about exactly what might have happened on day 4. And I'll talk more about that during this presentation. However, we must be very careful as biblical creationists that we're free to pursue all sorts of possibilities. Those possibilities must not contradict any clear statements in Scripture. That's always our touchstone we come back to. We want to ask, how well do our ideas conform with Scripture? If they don't, then we can reject them out of hand. If they don't contradict Scripture, on the other hand, then we can entertain those. And so it's at the same time, we've got the simultaneous problem with encumbrance of not having specifics, but then at the same also we have the opportunity to be able to explore all sorts of possibilities. Now, looking over what's happened over the past half century or so, I see that there are 3 themes that keep coming up again and again, particularly early on. I have some criticism about this. One theme about astronomy in the creationary literature was that there was a lot of criticism of evolutionary models. I sometimes call this Big Bang bashing, because the Big Bang model came to be widely accepted about the time the creation science movement, that was modern version at least, was launched in the 1960s. And so people feel that they have to show why the Big Bang model is wrong. And they do the same thing in biology, showing that biological evolution is incorrect. They also do it in geology, pointing out that problems with the uniformitarian assumptions about geology. However, we need to get past that at some point. We need to move beyond those points merely criticizing the evolutionary models. We need to build our own models. So Big Bang bashing, as I call it, can go so far, but we need to really do more than that. And also, some of these early arguments against the evolutionary models were improperly formulated. I've seen many creationary arguments against the Big Bang, for instance, that were not well done. And many of them had used out-of-date information, or many times just had a misconception of the evolutionary model, in this case, the Big Bang, or stellar evolution models, for instance. It behooves us to study deeply those models so we know what we're talking about when we wish to criticize them. Another of the themes that was pursued is argument for design, and I think I see a lot of design in astronomy. It's not as clear as it is in biological systems, however. Biological systems are very complex, and we can talk about the genetics and so forth of living things. But in astronomy, we don't have that kind of parallel. And one thing that stymied me is that we don't really seem to have a clear definition of design. It's one of those things that we think we can recognize when we see it, but I would like to have it more clearly defined, particularly in terms of creation astronomy. I think the definition in biology might be a bit different than what we find in astronomy. So I continue myself to pursue design arguments. On the other hand, I'm frustrated because I don't think I have a real good understanding of just what design is and how we can formally recognize that definition. And then the third argument people have pursued, and I've done this myself as well, is looking at evidence of young age. We do believe the universe to be young, so therefore we might find evidence of that in the universe. The only problem is some of these arguments for recent origin were later retracted. I'll give a couple examples. One is the shrinking sun that was popular a little over 40 years ago. Turns out the evidence for that is not there, I don't believe. And another one going back even earlier was the moon dust argument, and we've reevaluated that, and many of us no longer use that one. Now, you can continue to use it if you're very careful, but even then you ought to put some caveats because we might not quite be right about some of these things. So those are some of the three themes that have been there. But one thing that's missing in all of this is a positive building of a creation model. As I said in my first point on this slide, I think we need to be building a creation model, and criticizing evolutionary models will only take us so far. And it doesn't lead automatically. If someone accepts your destruction of evolutionary models, it doesn't automatically lead to a creation model or a biblically creation model. What we really need is to address those directly. And again, I want to emphasize no creation model really has emerged in astronomy per se. And there are three broad areas of interest. I think we need to divide these up into. I did a survey of creation astronomy about 25 years ago, and I pointed these three out then, and it behooves us to look at these once again. One is to look at the solar system and planetary science. One important factor there will be cratering, which I'll talk about a little later on. But why are there planets the way they are in the solar system? Why do we have Jovian and terrestrial planets, the two groups? Why are there other planets at all? Why don't we just have one planet, the Earth? Why are there exoplanets? These are all sorts of questions that we've really need to address in terms of creation. And then there's stellar astronomy. This is a study of stars. This has been my keen interest in my professional research over the past 45 years. And unfortunately, very little work has been done in the creation model in this particular area. It's kind of like the overlooked stepchild in all of this. And then finally, cosmology. And I think that's the thing that really piques the interest of a lot of creationists. Over the last 30 years, we've had a lot of discussion dealing with cosmology, alternatives to the Big Bang cosmology. And that inevitably leads us to a very big issue that it's the elephant in the room, as it were, and that is the light travel time problem. And I've discussed this again 25 years ago in my first survey of creation astronomy, which I presented at the 1998 International Conference on Creationism. That's the ICC for short. And I'll give a quote from that paper. I said, probably the single biggest problem that recent creationists face today. I was saying that about the light travel time problem, because if the universe is only thousands of years old, how is it that we can see very distant objects in the universe? And back then, over the years, we've developed several models. One of them was just simply mature creation. Henry Morris, one of the co-founders of the modern creation science movement, really liked that idea. Don DeYoung, who's still active, though quite retired now, but still active, he He likes mature creation, but a number of us have a problem with that. And also about 30, a little over 30 years ago, actually, the idea of CDK, that's shorthand for decaying speed of light, that was pursued by Barry Setterfield and a few other people, caused quite a bit of interest back in the late 80s, early 90s, but many of us backed away from that for a number of reasons, as many of us were backing away from mature creation. And then 30 years ago, again at the ICC, Russ Humphreys unveiled his white hole cosmology, and that seems to have a lot of appeal with people. And I hear people all the time referring to this. I was speaking to a creation group just a few days ago, and the person there indicated very much support of Russ Humphreys' white hole cosmology. What many people don't know is that Russ Humphreys abandoned that model 15 years ago. The word hasn't gotten out to a lot of people, but he no longer really supports that initial one. He moved on to another form. I call it Humphreys 2.0, and he published that around 2007, 2008. But then there was Humphreys 3, what I call Humphreys 3.0, that he published in 2017 and continues to develop even today. Now, kind of shortly after that, inspired by Russ, we had John Hartnett in Australia published several times on a five-dimensional solution rather than a four-dimensional solution of conventional general relativity. And he was inspired by an Israeli-Italian physicist named Carmeli, who had pioneered this idea. And Hartnett met with Carmeli and learned from him, and he was developing a model, even had a book published on it. Um, he since he's retracted that as well. He no longer supports it. Meanwhile, Jason Lisle was coming up with his ASA model, which stands for anisotropic synchrony convention, and people have a hard time understanding exactly what that's all about. He's published an early version in 2001 and then a much more advanced version in 2010, which many of us are still chewing on, and I think many people misunderstand that model to a large extent. By the way, John Hartnett has since embraced a lot of ASC in his writings. And then back in 2013, a decade ago, I published my preliminary work on what I call the Dasha solution. This is the idea that the light was rapidly brought to the Earth on day 4, not by a physical mechanism that the other three up there would invoke, but it would be a miracle that took place during the creation week. And I'm not going to spend much time talking about it because it's not about me. This is about the development of the creation model. I will say this, I sometimes call it the matured creation model, because rather than saying that God created the light mature coming from distant objects, I believe that the light actually left those stars, but God rapidly brought the light to us and in a sense matured that light. So um, we have many different models, and I find that encouraging. Just because I see people offering suggestions that I don't agree with, doesn't mean it's a bad idea. I might be wrong. In fact, they might be wrong. We all might be wrong. The big question is, are any of these correct? And we don't know yet. People take their choices, and we work forward on this. So I encourage other people to develop other models to try to explain this. Again, always going back to Scripture as our touchstone, our foundation, but then seeing if the science works as well. Now, there's been some progress in cosmology. In the past, we had many people believing space was created on day 1. That was certainly true of the founders of the modern creation science movement, John Whitcomb and Henry Morris. And that dominated. And I believed that for a long time myself, agreed with them that God created the space on day 1 in Genesis 1:1. And that then led to the atmosphere being made on day 2. And a large motivation for proposing this model of cosmology was to support the canopy model. Well, many creation ministries and many creation scientists long ago abandoned the canopy model for a number of reasons, which I won't go in today. But if you abandon the canopy model, then perhaps you ought to go back and evaluate what's going on in Genesis 1:1 and also on the second day in Genesis 1:6 through 8. And that's what I did about a decade ago to look at this. And we've taken a different approach entirely. There's an increasing belief that space was made on day 2. Humphreys endorsed that idea in 1994 during his first white hole cosmology, though many of us, myself included, didn't quite catch that at the time. And I then added to this in 2016. I believe that it's being covered there in my video. I'm sorry there, but perhaps the atmosphere was included with that creation of space on day 2. That's my intro. That's the rest of the text you're not seeing there. And I published that 7 years ago. And more and more people are coming over to this. Russ Humphreys, when he published his paper in 2017, I know Russ pretty well, and he told me, Danny, we're now in violent agreement. So we're making some progress. We're starting to converge on something. And a large part of this centers around the Hebrew word rakia. And the meaning there, it's a noun. It's something that's been stamped out or spread out. It's comes from a verb, raka in Hebrew, and it's generally understood that the meaning of this word is expanse, something that's been expanded. And its purpose was to separate waters below from waters above. That's given there in the day 2 account pretty clearly. And the waters below are pretty clear to most of us. It's talking about water here on the earth, particularly surface water, though there is maybe perhaps some subsurface water included in that as well. But what about the waters above? Well, the way we explain that and the way we interpret that says a lot about what we think the rakia might be. So what are those waters above? Well, people have made several suggestions about this. I know that Hartnett, back 20 years ago, he suggested that the waters above were now there today in ice bodies at the edge of the solar system. These are generally called small solar system objects, and they are include comets and asteroids, though they're kind of blurred out when you get that far out. There's not a lot of difference between them. On the other hand, Russ Humphreys had suggested in 1994, and I think he may still hold that, I'm not sure, that the water was synthesized into other elements and then we made astronomical bodies out of those. And I respectfully disagree with that approach. I think that maybe the stars were made out of nothing on day 4 rather than being fabricated. But I go back and forth on that myself. I've taken either side of that position at different times, and my mind is certainly not made up on that front. And then more recently, I've suggested that the water may be at the edge of the universe. And before I did that, actually, in 2008, Russ Humphreys suggested that. So he was a decade ahead of me on that one. However, he said it would think it was in solid H2O, that is ice. I'm of the opinion, again, in my paper from 2016, I think the word there, Hebrew word mayim for water, refers to liquid water, just as our English word water doesn't, when I say water, people don't usually think of ice or steam. They think of liquid H2O. So I'm inclined to believe that there's water at the edge of the universe. And then John Hartnett has also talked about, excuse me, Jake Hebert has talked about this in 2017. He kind of left it unspecified, which is fine because it is a little unclear. Again, you can't have too many models on this. The more models we have, the more we can compare them and sort our way through it. So I always encourage diversity in this as long as we're working towards a common goal and maybe can come to some sort of agreement here. But assuming what Russ Humphrey says, and I have concluded, and a few other people have, that tells us really that there's, well, both Humphrey's cosmology now and mine lead to 3 startling conclusions. Again, I'm not the only one who's done this, but I pointed it out in 2016 in my presentation. I think it was really my paper then. I think this was really an important contribution, one of the more important contributions I've done. And it's, I think, making a foundation for true cosmology. It's found in the Answers Research Journal, if you're interested in looking it up. That's online at answersingenesis.org, our website here at the ministry. And the three starting conclusions. Number one, the universe has an edge. And that's really wild because almost nobody believes that. And the Earth is near the center. If the universe has an edge, then it has to have a center. And the Earth is near that center. It doesn't have to be exactly at the center, but since the space and the water above were spread off of the Earth, if it was done reasonably symmetrical, then the Earth would have to be near the center. And then there's water at the edge of the universe. And I'm quick to point out that all 3 of these conclusions are incompatible with mainstream cosmology today. If I were to go to an astronomy conference and try to present this, I think it would not be well received at all because they don't think the universe has an edge. And if it doesn't have an edge, then it doesn't have a center. And even if the universe had a center, the Earth would be nowhere near that. The probability of that is extremely small. Well, that's because they're talking about naturalism, not special creation. And the idea of water at the edge of the universe is absurd to most people. But I think my understanding of day four and day two leads, particularly day two, leads to that sort of conclusion. Now, this leads to some questions. I want to get back to some of the other topics. Were the bodies that God created on day four, the astronomical bodies, were they created ex nihilo? Were they made out of existing matter? I alluded to that earlier. Russ Humphreys in the past has embraced the idea made out of material that he created out of nothing early in the creation week. I think John Hartnett has endorsed that. Myself, I endorsed that at one time too. I go back and forth on that. At this point, I tend to think they're ex nihilo, but I may change my mind tomorrow. We'll see. And and another question dealing with astronomical bodies, was there some process in their creation? This is something I've been stewing on for the better part of a decade. I note that during the creation week, many times people erroneously think that everything was created ex nihilo and created instantaneously. But that's not true about certain things. Like, for instance, creation of man, it was not ex nihilo. God made man out of the dust of the ground. He made woman from his side. And it indicates a process took place. It was a fast process, I'm sure, but still a process. And also, we find in chapter 2 of Genesis that at least the land animals and the flying animals were created out of the dust of the ground as well. That's a subtle point, but it's there in chapter 2 clearly enough. We see in the day 3 account of Genesis 1 that plants sprouted out of the ground. God caused them to rise up very quickly out of the ground. And Eric Hovind's uh, Genesis Genesis Paradise Lost showed it that way. And I was very glad to see that because I'd reached that conclusion a couple years before, and I think Eric and others had reached it before I had. And the dry land appeared on day 3. That appeared. It says that let the dry land appear, let the seas be gathered together in one place, and the dry land appear. That's again suggests the process. So were things created ex nihilo? Perhaps not. Some things were, but some things perhaps not. And were they created instantaneously? Well, there's plenty of evidence in Scripture that in the Genesis 1 account that things were not created ex nihilo. Many things were not, at least. Certainly, the beginning of all this had to be created ex nihilo, but some of the forming and fashioning did not require uh, that there be that it did not require that there be land stuff beforehand necessarily, ex nihilo or not. Um, so using that as a guide, if we see so many things being created not ex nihilo on the day the creation account of Genesis 1, maybe the stars and the other astronomical bodies on day 4 were also not created ex nihilo. Perhaps they were created out of material that God had already created earlier in the week. They were made or fashioned out of those materials. Again, this is debatable and certainly something that we ought to pursue on both sides of this issue. I've got my own biases about this, but people can differ on this. Another question is the effect of the fall. It was sacrosanct back 50 years ago. Nearly all creationists agree that the second law of thermodynamics did not come into play until the fall. But assuming that they said the second law of thermodynamics came into play at the time of the fall. But as it turns out, many creation ministries have backed away from that. Most creation scientists, not all, but most have backed away from that as well. A good example, the reason why we do this is because digestion of food is a good example of the second law of thermodynamics with increasing entropy. And they were certainly eating in the garden. Frictional losses, second law of thermodynamics. Without friction, you can't walk, and yet man walked in the garden. So consequently, you've got a problem if you try to say the second law did not come into play until the time of the fall. So I've written a study about this, dealing with astronomical bodies in 2013, again in the Answers Research Journal. And there's a companion paper written by Lee Anderson, a good friend of mine, and he pointed out that the effects of the fall were really overplayed back then. And another thing too is that many people argue that the craters in the solar system, not only on the moon, which is the most obvious to us, but we see craters on virtually every solid surface in the solar system, on Mercury, on Venus, on Mars. The only exception I know of is the innermost Galilean satellite of Jupiter, Io. It's been reworked extensively. So where did those craters come from? Well, many recent creationists think that they occurred at the time of the fall. And I think some of them were actually date back to the creation week on day 4. I think very little cratering occurred at the time of the fall. Again, that's a difference from other people, but there are some problems. I'll talk more about this a little later on. And then another big issue is the cosmic microwave background, CMB for short. And again, we've had some criticism, myself included, from the creation literature. For instance, a question came up with what's called the axis of evil and the great cold spot. The axis of evil is about a 60-degree long stretch in the CMB of higher temperature that cannot be explained by the Big Bang model. That's a big mystery. That's why they call it the axis of evil. Well, interestingly enough, it's aligned with the ecliptic, which is the plane of the Earth's orbit around the sun. And that's interesting because if it really is aligned with the Earth, could it be an LMB? That is a local microwave background. That's certainly a controversial suggestion. And another thing is, if the CMB exists, and it does, it's data, it's interpreted as the echo or remnant, if you will, of the Big Bang. It requires explanation within a recent creation model. If we don't believe that the CMB comes from the Big Bang, then what did it come from? And there have been a number of explanations in the past. One is that they suggest it was dust in the galaxy making it, but that really doesn't work at all. Russ Humphreys has suggested the Unruh effect doing this. However, again, tied to my cosmology, which I think is, again, my most significant contribution to date, perhaps, um, I think it's emission of water from the edge of the universe, and that's a explanation for the CMB that I like, and certainly talk about that. And we've kind of swerved into cosmology here, talking about that third piece, and this gets down to the nature of the redshifts. You know, Hubble in 1929 published his famous Hubble relation, where he showed a relationship between a function, if you will, between the amount of redshift galaxies have and their distances. Now that's observational fact. We can measure distances reasonably well, and we can measure redshifts pretty accurately. And when we plot them, they sure enough have a nice linear relationship with a little bit of variation. But that's fine. That's normal. Um, but what does it mean? And generally, it's understood to refer to expansion of the universe, and if such, it means that they're cosmological. And this is something that I wrote about 5 years ago, and I endorse this idea. When we say that when redshifts are cosmological, what it means is that it truly reflects distance in the universe. So when you see a large redshift, you know it's a great distance away. And not all people agree with that. Hartnett has disagreed quite strongly. He believes that redshifts are not cosmological, and we have a good relationship. But we're not antagonistic towards one another, but we do strongly disagree on this interpretation. And uh, it is an interpretation because there could be some other mechanism. If the universe is expanding, that would certainly explain the Hubble relationship. But what if something else going on and the universe isn't expanding at all? I think expansion is the best explanation. It's the simplest explanation, but I'm certainly open to alternative explanations. And some people will call that the stretching of the heavens. And I used to teach that myself as well. I've abandoned that now because I think the stretching referred to in about a dozen Old Testament passages, it refers to a past process. It doesn't refer to something ongoing today. And I think the best fit for that is the day 2 stretching that took place to make the expanse or the rakia in the first place. So when were those heavens stretched? Well, again, day 4 is one possibility, and John Hartnett and Russ Humphreys have both done that. But I think day 2 is a better fit, though the word rakah is not used there, but the word rakia is, and it seems to be the output of one of these things involved there. Now, there's also the issue of quantized redshifts. This was something that was put forth by Russ Humphreys a number of years ago. He may not have been the first, but he certainly talked about it 20 years ago. And the idea with this is that we see, going back to the mid 1970s, a man named Alan Tift, an astronomer, noticed that redshifts are not uniformly distributed, not continuous is the right word in mathematics, but rather if you do a histogram of redshifts, that you see peaks that occur, and one of the peaks is around 72 kilometers per second per megaparsec. And that's interesting because it's sort of reminiscent to the quantization of energy states and electrons in spectra done in the late 1800s. However, there are exceptions to this rule. If you do a histogram, it tends to kind of go up and down and has peaks, but there's still a lot in between those peaks. And so it's not a strict quantization quite what you get from quantum mechanics. And Bashard, shortly after Humphreys wrote about this a lot, he disagreed with that interpretation. And Jake Hebert and Jason Lyle published several papers back almost 7 years ago now, um, where they considered possible bias in the observations. And the bias is coming about through the fact that we see clumping in the universe. In fact, it was first discovered about 40 years ago, and it's been improved upon and actually well established that galaxies tend to clump in shells like this, and bleed along sheets. In fact, there's like a filamentary structure. It's like Swiss cheese with really big holes in it, and so the matter is distributed along those planes and sheets in between them, some of them having a spherical sort of distribution. And these are on a gigantic scale, a huge scale. So if we're looking out through space, you're going to be looking through those sheets as you go through. And so you're going to see what you think are voids in between. And because those are related to distance, because I think redshifts are cosmological, then you're going to have peaks and valleys in that distribution. And it's called the Malmquist bias that Hebert and Lyle talked about. And I find their argument very convincing. In retrospect, it should have been one of those obvious things that we see. So it may just be an artifact. There may not be true quantization. But what people got excited about was the fact that if indeed the redshifts are quantized, assuming discrete values, and you assume the distance, they're cosmological, then you end up with concentric shells around the Earth. The Earth is here, and you've got concentric shells of galaxies, and that kind of suggests, again, some sort of creation model with us at the center. But again, it just because we see that doesn't mean that's the proper interpretation. I think it could be because of the clumpy nature of galaxies and matter in general in the universe. Speaking of which, matter, one of the huge issues we've argued about over the last couple of decades is dark matter. Um, is dark matter real, or is it something that they've simply made up? If you don't know about dark matter, it's been discussed now really since the late 70s. I was coming along in grad school about the time of the transition. I need to emphasize that the evidence for this goes back to mid 1930s, but it was largely ignored for 40 years. Astronomers did not like this, but it appears now that about 90% of the mass of the universe is in a dark form. And that's interesting because it can't be normal baryonic matter. If it were, then it would radiate. And so it would interact with radiation, and it doesn't. So there have been many candidates searching for this, and the problem is the fact is it seems to be there in the data. It really is. And so a lot of discussion about this. I emphatically say yes, dark matter does exist. I wrote a paper about this in 2017. I also recently presented upon this in the ICC earlier this year, in July of 2023. I gave what I thought was a very persuasive argument for dark matter. It built upon this earlier paper that I'd written called The Case for Dark Matter. That too is at the Answers Research Journal, but the ICC is at a separate location, but it builds upon that. And I think there's a very strong case. On the other hand, other creationists disagree. Hartnett disagreed. Um, uh, Warwicker, he's in favor of what's called MOND, and MOND stands for Modified Newtonian Dynamics. That there's something funny going on with gravity. It works at the local level, following a good Newtonian description, but when you get to the order of thousands of light years, then gravity deviates from that, and so you can modify gravity in such a sense that its effects of this little effect would not show up locally, but on a large scale, it would. And I've puzzled over this for some time. Why are so many creationists opposed to dark matter? And I think there are a couple of factors going on. One of them is that they view it as a rescuing device because many creationists didn't start paying attention into dark matter until the 1990s or early 2000s, and that was when cosmologists began to invoke dark matter, and dark matter became a a free parameter that you could play around with. You could explain galactic structure, the structure of the clumping in the universe, and so forth. And so now it's it's one of those big issues in astronomy and cosmology. And unfortunately, many creationists didn't start paying attention to dark matter until that came along. But I was in grad school when the evidence for this was finally being considered, and gradually, and I must say very reluctantly, by astronomers. They resisted this for decades. And it was not based upon anything it could do for your evolutionary models. Rather, it was just driven by the data. Once astronomers began to recognize that dark matter likely exists, then they turned around and said, okay, now we can use this to explain things in our evolutionary models like the Big Bang. So again, I alluded to before, I had a paper I wrote on this in 2017, but I expanded upon it and presented this summer, just a few months ago, at the ICC, and that should be online there. And it's emphatic no. I want to make it very clear. And what I showed there is 3 lines of evidence for it, dealing with the operational science, not the historical science. And I think above all people, creationists should recognize the difference between those two. We certainly uh, we certainly should understand that we shouldn't confuse origin science, historical science, with operational science. And I think the operational or observational science for dark matter is very clear. And that was my emphatic point there. And uh, I think another argument can be that there's an attempt to preserve evidence for recent origin. And I've got several authors there, Michael Ord, Safferty, and also Keith Davies. And this goes back really probably to the 1970s. I think it was Harold Schlusser who first pioneered this. We see clusters of galaxies that seem to be expanding. The galaxies seem to be moving apart on a time scale that would cause the things to just totally disintegrate or evaporate away in a matter of a couple of billion years at most, probably even less than that. And if they've been around for, say, 10 billion years or more, why are they still there? And this is called the missing mass problem for a while. And it was a kind of a nice argument. It didn't tell you it was 6,000 years old, but it seemed to eliminate many billions of years old universe. Well, this is one of those recent origin arguments I think that maybe we have to get rid of, because one of the lines of evidence comes from the expansion velocities we seem to see in clusters of galaxies. But if there is dark matter, then these things are stable. And in fact, that if in order to argue that that this argument is valid for recent evidence, you have to then throw stability away, and that's an argument that many creationists have argued. They argue about the stability of the Earth's orbit around the sun, the planets, the natural satellites. All these things naturally in the universe seem to be stable, and all of a sudden we get to large clusters of galaxies. Well, we want to throw that stability argument away, and that's just a wee bit inconsistent. I believe. I think we need to be consistent on this front. So I'm very bullish about dark matter, and I find that most, if not all, the creation scientists who happen to be astronomers like it. It's the physicists who don't seem to like it, and I think it's just because they're not really aware of the long history of how we came to understand that dark matter exists. Okay, getting closer to home, how do we explain craters? And there have really been 2 camps. I alluded earlier that many people thought at one time maybe they happened at the time of the fall, but really many people like the flood-related ones. Michael Frody, Michael Ord, Holt, and Spencer all have endorsed that sort of idea. But I've gone in a different direction. Um, I think there are some would be flood related. I think the large impact basins on the moon would, for instance, would be that. But I think that and Maurer and DeYoung also endorse this idea as well as Ron Samick. But on the other hand, um, I've suggested that there was a day 2 day 4 impacting going on. I think if God created the bodies in the solar system, particularly the moon, out of material that it had created earlier, ex nihilo, then maybe some of the impact craters on the moon would be a result of um, some of that formation process going on. And so this suggests really that there are 2 episodes, not just one going on. And I've won some people over to my line of thinking. Michael Ord, for instance, a decade ago, considered some of the heat problem generated by it, because you get a lot of heat generated by impacts, and doing it all at the time of the flood would be very problematic. I did some calculations there, and a few other people have considered that too. And so some of these people have kind of migrated over to my line of thinking that a lot of the craters may date from actually day for creation, and there's no heat problem there because it is creation. And I don't think the laws of physics as we know it were quite operating yet. The whole creation week was quite miraculous in what it did. And I mentioned earlier about the small solar system bodies. These collectively include the comets and the asteroids. And so where did they come from? Were they part of the initial creation? Well, I happen to think they probably were. But there's this idea of a disrupted planet. This idea of Parkes in 1990, Froda and de Young in 96. And the idea goes back before that, that there was a planet that was existed. Either it was tidally distorted, disrupted, or by another body coming by, or maybe it collided with something. This idea has been around in conventional astronomy for probably 200 years. I think it's a problematic one. I don't like it. And then Andrew Snelling has done really excellent work a decade ago looking at the dating of meteorites, had a multi-series of papers in the ARJ on that. And I've also commented more recently that there's a blurring distinction between comets and minor planets, or if you will, asteroids. These were very distinct bends for much of my life. Something was either a small body is either a comet or is an asteroid, but in recent years we found that they have similar properties. So it's more like a spectrum rather than two distinct bends. And I think we need to take that in consideration in our creation model. And then planetary astronomy, that's interesting. Venus is an interesting planet. There's been catastrophically reworking of the surface, and Bob Hill presented on that at the ICC in 2008. However, the next year, Michael Orr disagreed with some of conclusions that Hill came to. And then Mars is another one. There's indication of catastrophic episodes going on at Krieger in 2008, Samick a decade ago in a couple of papers. What's fascinating is that Mars is a secular scientists back in the 1990s concluded that there was a global or near global flood on Mars. This on a planet where there is no water to speak of. And yet it couldn't happen on the Earth where we got tons of water. And then Venus has catastrophic plate tectonics, something like it going on where the surface was completely reworked and not too distant past on the evolutionary timeline in a very short order. It's almost as if the Lord had this happen on the closest two planets to us, one catastrophic upheaval of plates, and on the other one, catastrophic flooding, so that this late date in the 21st century, we could actually look at that and see some differences. Similarities to the Earth, maybe both happen on the Earth, and here's evidence of that possibility. We don't yet have a coherent theory of planetary astronomy, why God made the two types of planets, why he made 8 planets, and this sort of stuff, but we're working on that slowly but surely. And then exoplanets, these are planets orbiting other stars. The total now is approaching 6,000 of them. And what's interesting is that none of them are Earth-like. Spencer has written about this. I've written about it as well more recently. But none are Earth-like. And that's interesting because the whole point of looking for exoplanets was to try to find Earth-like planets. And we haven't found them. And so that led me to the conclusion, based on the science, and it agrees with my scriptural, by the way, scriptural argument, we are alone in the universe. And I find that interesting. So my conclusion, I think we've found an increasing number of the creation papers dealing with astronomy over the years, and that's a good thing. If you recently someone did a survey of these, surveying what the number is, and it's very encouraging because we get more and more papers being done. Astronomy is now being discussed far more than it ever has in the past, and I think that's a good thing in the creation literature I'm talking about. And there's much less evolution criticism than there used to be, and I think that's a good thing because we need to spend some time building positive models rather than just trying to tear down our opposition's models. And so we need more model building. That's what's really important. I'm a member of the board of the Creation Research Society, and research is our middle name, we like to say, because we like to promote research, and I encourage creation scientists of all to do that. And lastly, I'll point out that a number of books have gone on, and have been some astronomy meetings that have been done along these lines as well. And just a couple of key issues. Dark matter, we need to settle on this. Dark energy, I didn't talk about. We need to talk about the data for that. And when were the heavens stretched? Again, I'm very bullish on that being day 2, but we need to discuss this and also the evidence of craters, where they came from. And last but not least here, I really think we need to talk about stellar astronomy more, because that's my passion, and yet it's really hasn't advanced at all in my lifetime. I want to see more going on there. Here's my concluding slide to tell me I'm at the end. I just took this picture a few days ago during the annular eclipse here in the southwestern United States, and I thank you very much for your time.